Hello, everyone. Seems like we live now. So we have a special edition today. We're going to be talking a lot about migration. But before of that, let's take a look at some other things that we have available. So on the agenda today, Alex is going to be highlighting a little bit of the AIS Aviator of the month. Then Kent is going to be talking about the product group news. We're going to have two special guests, Hugo Girard, that is going to be talking about BizTalk to AIS Migration, and then Derek Marley is going to be talking about MuleSolf to AIS. You wanted to stay until the end because we have like a top secret community event that we've been cooking together and are going to be announcing that today. And after that, we're going to have Q&A. So with that, over to you, Alex.
Alrighty. Hello, everyone. And so I'm going to be talking about October's AIS Aviator of the Month, which is Harris Crisanto. So for those of you who don't know who Harris is, he's an integration developer at Bid1. And a couple of highlights from his post is to, one, have an open-minded STEM. With the world constantly changing, don't become fixated on a single thing. And Harris also thinks it's important to give back to the online community with guidance and solutions. So he spends a lot of his time filling those gaps. And lastly, another fun point from his interview we had with him was lastly, some important lessons is to, for a successful career, always have some goals in mind, whether big or small, and don't forget to rely on people around you for help. So with that, if you want to check out more about Harris's response and what he does for our community, head over to that link at the bottom, aka.ms/logicapp-aviators/October 23. And I'll hand it off to Kent, talk to you guys about some more exciting stuff.
All right, thanks, Alex, and thank you, Harris, for all your community efforts. We really appreciate it. I wanted to spend just a couple minutes just making sure everyone is up to date with the latest news coming out of the product group. Now, some of these topics are things that we've talked about in previous community stand-ups, so you can feel free to look back over there. And also go ahead and check out our blog where you're going to find more information about these items as well. So first off, Application Insights Enhancements, otherwise known as V2, has reached general availability. So you can now go ahead and enable the V2 schema and use it for your production workloads. V1 will continue to be the default, probably for the next couple months, but you can go ahead and enable this inside of your host.json file for Logic App Standard and be able to emit data using the new schema. So go ahead and check that out. We also announced last week the general availability of .NET Framework custom code. So this allows you to go ahead and build .NET Framework custom code inside of a project, compile it. We're going to bin place it into the Logic Apps workflow project, and then you can go ahead and call this compiled code from a built-in action from inside of Logic App Standard. So if you're looking for extensibility options, you don't want to have to provision another service in order to do so, this is something that you definitely want to go ahead and take a look at. Also, just wanted to share that we're also working on .NET Core support. So that's something that you should see in the near future. We'll talk more about it on an upcoming Logic Apps Live community event. We also released in public preview the ability to submit from an action. And so this has been quite the popular feature. This allows you to go into a run history and then be able to resume from a particular point in the workflow of your choice instead of resubmitting from the very beginning of the workflow. So this is another feature that we're quite excited about. It is in public preview, but it's fairly low risk, and you can go ahead and check that out as well. Now, we've also, and this is something that we just sort of emerged here rather quickly, so I don't think we have a blog post on this one, but I do have a video on my YouTube channel, is we do provide copy and paste functionality now in Logic App Standard. And so you can do this inside of the Azure portal or from VS Code itself. But this is something that folks have been keen to use and been looking for quite some time. And last but not least, we do have some data mapper updates that have been made recently. If you go ahead and update that extension, you're going to see some of the new capabilities showing up there. The latest is the ability to go ahead and move around the functions that you've gone ahead and created, so giving you more control from that perspective. There was some bug fixes, and we will have some upcoming news next month around GA. So that is right around the corner and something to look out for. So with all of that said, go ahead, check out the blog, aka.ms AIS Tech Community. This is our tech community blog, and you'll find more information about these different announcements. All right, so with that out of the way, we're going to welcome our first guest. Hugo works for Microsoft Canada as a senior cloud solutions architect. He's been doing a lot of work recently with BizTalk server to AIS migration, and really interested to learn more about his experience. So Hugo, over to you.
You again?
Share your screen, yeah.
Yeah. So hello everybody. So today I'm going to talk about BizTalk migration, and basically, like Ken said, I'm helping our customer in Canadian market, to do this migration, and it will be mostly general architecture, So this is the agenda of today. So it's like basically why people are migrating to Azure integration services, the challenge that they are facing. Obviously, it's not like straightforward. Most of the service that they use in the AIS stack. And I will talk about two cloud patterns that I see coming all the time: the external configuration one and the circuit breaker. And I'll explain why they use it and the importance of it. I will go a little bit more about Azure Service Bus, because this will become really the core when you will do the migration. It will handle all the routing, and all the message will be saved there. It's a little bit like the message box in BizTalk. So in the cloud, Azure Service Bus take that role. Since I cover a lot of healthcare customer, MLLP protocol is really used, in healthcare, like for hospital and everything. And this obviously is not supported out of the box in Azure. And I will see our customer like handle this use case. And monitoring. Here, I'm not talking about Azure Monitor or application inside. It's more like a pattern that I see that our customer are using to do debugging in their integration. So basically, there are two main reasons why people move to Azure. First of all, like BizTalk Server 2020 will be end of support like in April 2030. So people have a lot of integration, and now they start to think, okay, it's a good time maybe to start moving them to the cloud. And even have some customer that they are still in 2016 and they don't even want to go to 2020. They just say, okay, let's just do the cutover and start moving. Plus, I have other customer, they just start to move a lot of workload in Azure, and for them it's just a good fit in their roadmap to kind of cut all those legacy system running on-prem, and they try to move as much as possible their integration to Azure, or even their downstream system or source system that they were having in the integration stack to move them to the cloud. And there's kind of two way our customer handle that. Some, like I said, will do a migration to 2020 to gain some more year, or they would just keep BizTalk on-prem, but they will start moving all the integration to the cloud. So BizTalk will be mostly a proxy, and when all the integration are moved, they just remove BizTalk. So the challenge, obviously, BizTalk is a good solution. So company did a lot of investment to it. They have a lot of integration to 300 and even more. They have developer that they build all their career on BizTalk, so they're really good at it. So when they need to move to the cloud, it's a different mindset. Now you talk about distributed architecture. It's a new approach. So this can become a challenge. Sometimes they think we have kind of one solution, kind of replace BizTalk per se, one thing that have everything, but no, you need to use multiple services to achieve this migration. Like I said, a lot of healthcare customer, and most of the healthcare solution use this MLLP protocol. When you go with the HL7 stack, we don't have any, as today, connector and logic app that are native for that. So you need to build around it. So this can be a challenge, because sometimes our customer, they would like to have just something that they can use in logic app, and they handle that for them since it was present in BizTalk. Monitoring, it's more complex, obviously, because before you were opening BizTalk, the console, everything was there. Now they need to monitor multiple services like Azure API management, the service bus. Yes, they leverage probably application inside, but now we're talking monitoring distributed architecture end-to-end versus one centralized solution. Dead letter queue, since service bus would be kind of the core of everything, the minute you still have for the FIFO that is needed, first in, first out, sometimes you cannot have a dead letter queue. For example, if we take like a healthcare industry, so you go to the emergency, like you will have the system of the emergency that will create an ADT transaction that would be like a registration. If the message go to the dead letter queue because the downstream system is down, and the next message that comes is when you discharge from the emergency, you can see the problem coming, you know. So even if it's a good concept like in service bus, dead letter queue can create some problem for a customer, because before, the way they were handle it in BizTalk is like, if the downstream system was down, BizTalk were just like trying to send it like forever. So if it send it like 20,000 times, that's fine. But you know, when you move to the cloud, you cannot really do that. It's a different kind of a mindset you need to have. Another challenge, all those new cloud design patterns that you need to implement. Like I said, circuit breaker, external configuration store, and I will go deeper into that later. But you know, it's like not like BizTalk that you're having like your receive, send port, you do your mapping, and you're good to go. Now you need to kind of code around like your logic app, your function, your service bus to achieve like some like behavior that you were having in BizTalk. You need to learn a lot of new services, again, like logic app, function, so a lot of skilling to do. And the last one is, as for today, you don't have like kind of this centralized pane of glass for all the integration, meaning most of the time an integration will have like multiple component, like the topic, after that the logic app, maybe the logic app will call a function, this will pass through Azure API management. So you will like to be able to catalog all those workflow function together and say, oh, this is this integration, Contoso, this is the Acme integration. As for today, you don't have that. Maybe you can use some tagging, but customer, you know, said, oh, they would like to have this centralized view. So basically, this is like the services that I see the most used by your customer. Azure API management, when you will start developing your logic app, the one that are HTTP, obviously, everything will pass through Azure API management to protect, have a single point of entry. And even let's say you have like some downstream systems that are SOAP or REST-based, you will pass through APM. Service bus, like I said, it will become like kind of the core between your source system and your downstream or destination system, is the one that will receive all the message, handle all the routing. Obviously, logic app is kind of like the go-to for the migration from BizTalk, you know, with the data mapper, all the new functionality that the team are developing. So this is kind of like the tool to use to help you with your migration. Function is still used. You know, sometimes like you have like specific business logic and you want to implement it through code. So that's perfectly fine. And customer asks all the time, like, oh, which one I should use, logic app or function? It's not one or the other. Most of the time it's like a mix of the two, you know, a logic app can call a function and so on. And the last one is data factory. This one is more edge case so far, but you know, they were having like big integration that is like a big batch, and the file is like a couple of gigabytes. So data factory, that's the tool, sometimes a little bit better than serverless. Okay, so the first pattern that the customer implement is the one called external configuration store. And behind the scene, they use like Azure App Configuration. And there's two specific use cases for that. The first one is to keep all the configuration of all your routing that you're going to do. And by routing, what I mean is like you will have one logic app that will be mostly generic, that will receive the message from all the source system. After that, read some value or property in the message and save it in metadata in the message and service bus. So if you see to the right here, I have a configuration, and basically I just say here what you need to read in the HL7 message that you see here at the bottom. So you're going to go in the MSH segment, and at different position, you will just extract the value. And those value that you're going to extract, you're going to save that as metadata in the message of service bus. It's kind of like key value. So you will have probably like the key MSH3 with the value HIS. And why you want to save that in an external configuration is since you build those generic logic app that will just read the message and do this metadata, you don't want to, let's say, do some code change. Obviously, you can put it in the app setting, but you know, there's some downside of that. If you go to the app setting, you do some modification and you click save, and sometimes this will restart the logic app. So you really just want to have like something more automate like with CI/CD. You just modify like some some routing, let's say you want to extract now like some information in the PV1 segment, you will just modify here, save, and when the logic app will run next time, we'll just retrieve the latest configuration, and nothing to change. And it's a little bit the same concept when you will create your subscription inside the service bus. So in this case, you will probably have like one or multiple topic. Right now, I have like this only one, the integration, and inside the integration topic, customer will create one or multiple subscription. In this case, I have two, and they will apply like filter, on top of those subscription. And again, you want to put that in the external configuration store because customer were asking like, but I don't want to go, let's say, inside the Service Bus Explorer to modify my filtering or create new subscription. They want something more automate, and they don't want to do any code change again. So maybe behind the scene, you're going to create a logic app or a function that will just read this configuration, create new subscription, remove some subscription, or even modify the filter. So now that's good. You have all your information saved in the external configuration store. And this is what will look like in a high level. Obviously, this is more simplify everything now, like the source system and downstream system use REST or SOAP, but it doesn't matter. Like here, the logic app will have a connector, let's say, to read from IBM MQ, retrieving a file from an FTP server. So how it works in a nutshell, and this is kind of like the architecture, the kind of like the general pattern that we see for most of the integration. So you'll have a source system. In this case, we'll send through a RESTful API that is a generic logic app, and the logic app is protected by Azure API management. Now the logic app will retrieve like the configuration that I was telling you about the routing. So it will just extract specific position in the HL7 message. It doesn't need to be HL7. You can apply the same logic, and I saw it. Like I have customer, they use XML message, so they just read specific property. And they save that when they create the message to save in the service bus, they will create what we call custom property. So it's kind of key value. In this scenario, you will have two subscriptions because you have like two integration, like one that is Contoso and one that is Acme. And let's say you apply the filter for each specific subscription, and you send 3 messages. So the first integration based on their filter will receive like the 3 messages, and the second one, the 2 messages. They will after that do the transformation that they need to do for the downstream system. In this case, both downstream system are REST or SOAP, so they still pass through Azure API management. If it was like a IBM MQ, obviously they won't pass through APM, it will go straight to IBM MQ with direct connectivity and using the connector and logic app. So as you see, like it's easy after that. When you add more integration, basically you create a new subscription, you create the proper filtering, and you just need to modify like this external configuration store and obviously deploy the code, and you're good to go. And this is just like a view of what it will look like if you are using the Azure Service Bus Explorer. Basically, like remember, I show a configuration that you are creating 2 subscriptions, so they are there, consumer A, consumer B, and inside that subscription, I was having a rule. So the rule basically is this one, and the filter that I was showing. And this is like really more like SQL based. So where and or, I was having those customers, they were like big kind of complex routings. Like if this MSH tree, it equal this value n, and after that they were having a or close with a bunch of hands, so you can really create complex filtering rule. And this is just to show when I was saying like when it's saving the service bus. So here is your HL7 message, and you see it's all kind of like the metadata, basically the value that I extracted, with the generic logic app would be saved here in this metadata. So you will have like a MSH3, 4, 5, 6, and the value that you have at that position. Again, can be an XML message, can be any kind of format, would be the same concept. And basically, that's where you base after that your filtering for the subscription. So the second pattern that we needed to implement with the customer, it's all about like this dead letter queue. So behind the scene, service bus, how it works, when you send a message to a queue or a topic and you read from it, and let's say you don't tag it as complete, it will expire after a while and you will increment the property. After X amount of trying that you don't mark the message as complete, it will go to the dead letter queue. And again, some customer, they didn't want to have this dead letter queue because like FIFO, it's like really critical for them. Obviously, you can increase this amount, but you can even put it, I think, like to 2 million, but you don't want to do that, in a distributed architecture. Like that would be like a bad way to think. So that's where you implement the circuit breaker. So at the end of the day, this is really to avoid reading all the time the message if a downstream system is down, and after that send alert, and obviously just like read and send when the downstream system is back up. And the goal of the circuit breaker is like you have multiple statuses. So the first, it's closed. So when it's closed, you read from the queue, you try to call the downstream system. If it's down, you mark the message as complete, and you're good to go. If it fails, you increment a failure counter. When you reach a certain threshold, then you will pass the statute to open. So basically, that's it. You stop reading from the queue, and it's just like automatic failure. After a timeout or a certain period of time, you will pass to fopen. Fopen is like you will retry, but let's say like not like in a normal flow. And again, depending what happened, you close the circuit breaker or you reopen it. So if we put that more like logic app perspective, what it will look like. So you will start your logic app probably with, in this case, maybe a recurrent timer trigger. Next, you will read kind of the value of your circuit breaker. Like I said, if it's open, that's it. Nothing happened. If it's closed or half open, then you will try it. You'll probably read a message from the queue here. You will, after that, try to send it to the downstream system. If it succeeds, you just mark the message as complete in the service bus, and you update the value of the circuit breaker. If it fails, you will abandon the message, meaning it will go back to the queue or the topic. You will update your circuit breaker. And this is the part that is important. You will send an alert because you want the IT team like, oh, this downstream system is down. And when maybe the timeout will fail again, and you retry, and it's after 10 retry is still like failing, then maybe you want to send another alert, but do a more critical action. Let's say disable the subscription. If you do that, you can still receive the message, but even if you try to read from the topic, it won't work, or you just like really stop the logic app. So because like, hey, this needs to be fixed. And again, all of this logistic that you need to implement is really for the dead letter queue. If FIFO is not necessary, you don't care about that. That's really more like really use case, and mostly in healthcare that FIFO was really critical for them. And now that I was talking about healthcare a lot, basically they use like MLLP, most of the time in healthcare industry, they have like all those software from third vendor, like the emergency one, the laboratory one, and so on. And the protocol that was used back then was MLLP. Basically, it's just like TCP communication with some like more information on top of the message that they send. And sometimes they don't control like obviously those third-party vendor. It's not so easy to say, okay, tomorrow send me everything to HTTP, or they want to not have like breaking chain. So they needed to keep like this MLLP protocol in place. So I saw two kind of solution that customer implemented. Some that on top of this talk were using other kind of integration solution, let's say MERT, that one is really popular. So because of that, they just use it as a relay, or they will deploy a third-party solution as a relay. This one, his job will just receive like the message to MLLP protocol, and he send it directly to HTTP to the cloud. The downside of that is like some customer don't like it, because obviously it's like, oh, now I remove this talk, but I need to install another piece of software. If you have high amount of volume, like I was having customer with a 40-50 million message per month, now like some of those solution was not working. So in the case this doesn't work for you, the other solution is to develop like your own MLLP connector. So basically, you will just create a simple TCP listener that you will host like an orchestrator. It can be Kubernetes if like customer already have a Kubernetes cluster in place, or Azure Container App if like they don't have like the team, or they just want like something more managed. And the goal is pretty simple. You develop this listener, you have your orchestrator obviously inside a virtual network, and you have direct connectivity through an express route or a VPN. And because you have direct connectivity and you have like everything would be like obviously through private traffic. So the listener will just open a port, and you would just provide the IP basically to the downstream system. So if it's like the laboratory, for them, it's just an IP change, is the same port. The message will be reached through TCP communication in the cloud. And after that, obviously, when the proxy receive it just continue doing HTTP. And the goal of this kind of listener or proxy is really to be lean. You don't want to implement a lot of logic because it's just kind of like to handle communication. And it will be a little bit the same if you go the other side. So you have like some stuff running in the cloud that need to communicate to something here that would create a TCP connection and send it to the downstream system. Obviously, when the downstream system is still on-prem. And the only thing here probably would be a web API. So like, because, cloud is mostly RESTful, so you would probably send to a web API that this one will create like a TCP connection, but the web API will be really lean. Again, the goal is just I receive a message and I send it somewhere. And customer probably would create multiple listener because they have multiple kind of like a system that send or receive. And the last thing I wanted to talk today is like monitoring. And like I said, this is not about application in Azure monitoring. Obviously, customer will still use that. But I saw that more with my healthcare customer, and now some others start to adopt it. So basically, you have a source system here that would send like a message to the generic logic app. And this one, both like the one that receive like the message and just save it to the bus, and the one that do the transformation will save it in Azure Cosmos DB. And this is really just for short-term debugging. So what they want with that is like, okay, I will log like I receive like a message from the Contoso system. The direction was a source system, the date of connection, and they save the HL7 message. If it's XML, obviously you will need to do a transformation since Cosmos is JSON. And the same thing, when they do the transformation here, they will save like, again, like, okay, this is going to the Acme system, the direction is destination, and they save the transformation system. And they probably put a time to live on those messages around 90 days. And they like it because, they can just do a SQLite query and they retrieve information fast. But on top of that, customer will still like save like the original message and then transform message. And this would be mostly long-term archiving, compliance, or sometimes, since they don't have control on some of the downstream system, the one that send the message, they say they can like open like, no, you send me this, so what you send me is wrong, so they can consult the message. Or even more, let's say a downstream system is down and for X reason you want to replay a specific one or more message. This would be really easy since you have like the copy. You can just like pass them again to this logic app, will save it again to the bus, and all the needed integration can replay them. Or you create even a generic logic app here that you pass the transformation message to it, and it will send it back to an entry system. So nutshell, they keep that really more like long-term debugging, compliance, or just replay specific integration. And here is like just like they really like it for quick time debugging. You can even put Power BI, like some of the customer now they talk about analytics. So that's one of the reason and one of the pattern that I see that they start to implement. And that's it for me.
All right. Well, thank you, Hugo. Did we want to take that question now, Wagner, or should we wait till the end?
I think it's a good idea. Let's take it because it's just one. Let's take that one here, and let me adjust this. So engine, what is it? This one here. Engine was asking if how to be able to migrate complicated maps.
Yeah, I think to migrate that, we'll probably do all the logic, like in logic app, like this is really like kind of like high level pattern just to get like your source message, save them in the bus, and after that, all this kind of heavy logic that would be pretty reside in logic app. This is really high level or to move the source to the destination.
Mm-hmm. I think the other thing to add there as well is like if you've got your BizTalk maps, those are things that you can lift and shift into logic apps generally quite easily. So you can, even if you've got scripting functoids, we're using .NET, like I said, functions that are part of that, you can move both of those as well. So that is something that is in GA as well, if that's sort of the path the customer wants to go down.
Yeah, so if you needed to do a bit, you were able to do lift and shift with the maps, and it's one of the things that we try to bring from the beginning, because most of the time this is where part of your logic is going to be. And on a similar note, Kent, the whole idea of the custom code starting with .NET Framework is to be able to bring some of those things inside orchestrations on the pipelines that you were not able to do before. To again lift and shift instead of you having to rewrite a lot of things, right?
Yep, no, that's exactly it.
Harold, I know that you work a lot on BizTalk as well. Any views on that one? And you're on mute, just in case. You're on mute, mate.
Sorry, the one about complicated mappings?
No, about
overall.
any of that.
Yeah, I think it's a journey, right? I think overall, starting with the low-hanging fruits, it's the approach that we should take forward. I think we and our customers, we all know that architectures are fairly different, right? So then there has to be refactoring is implied, right? It's just that to some degree, it depends a lot on the scenario that we want to cover, right? I've been working with BizTalk since BizTalk Server 2000, and believe me, I mean, there's been a lot of changes from there when it was Visio based. Because I don't know if you've seen the orchestrations back in the day, when they use Visio libraries, right? But it was quite interesting, So now where we are at Logic Apps, it's been a progression, and we have to keep adapting, right? So same with Mapper, continue growing. Same with the rest of the features that we are building as well.
Okay. Well, I think that was the only question that we had so far for the BizTalk. I'm pretty sure there is some more that is going to come. So in this case, let me bring Derek to the fold, and then I'm going to disappear. So all yours.
Yeah, so our next guest is Derek Barley. He's from Horton Cloud Solutions, and he's going to chat with us about migrating from MuleSoft over to Azure Integration Services. So thanks for joining us here, Derek, and I'll give you the floor.
Okay, let's jump in. Just going to get going here. So I'm Derek Marley. Essentially been doing integration for 25 years. Last portion of my career has been focused in the MuleSoft space, Azure Integration Services space. So this topic's near and dear to me. We have clients now looking to migrate off of MuleSoft and onto platforms like AIS. So that's what this talk's about. So yeah, Horton, we essentially focus on systems integration, which works well for this talk. We've been doing a lot of the migrations recently. So that's what this is going to cover. This slide's just to cover off some of the things that we're hearing from our customers. Some of them, and really it's the left-hand side of this, which is really how can they've been using pay-per-use model for a while now, and they want to understand how with systems integration, how can they get into that same with MuleSoft? They have more of an annual subscription model, so they want to look at how they can not do that. Compute planning, the way the cores are sold, and you have to continually purchase more cores and maybe not the best optimization of the cores. And then ultimately, how can they get a better return on investment with their integrations? After migrations, we're seeing on average an ROI of about 1 to 1.5 years after the ROI or after the migration. And after that, they're seeing upwards of plus 80% reduction in their platform fees. And of course, they want to see alignment, unified team experience, and unified environment for security, networking, things like Sentinel. So that's working well for them. As you go through this migration, there's things that you have to consider. And obviously one of them, MuleSoft, and we're going to go through it in the slides below, they have a very clear architecture that they want you to follow. So customers are concerned, are we going to have to re-architect everything? So you'll see below we have a strategy to prevent you from having to do that. Resourcing duality, you need MuleSoft expertise, you need Azure expertise, so just know that ahead of time. Release management, obviously stay away from big bang approach. Customers usually don't like that when they think about migrations. So how are we going to address that, which are covered below. And then ultimately, because it's on an annual subscription, usually those 3 to 5 year terms, you have to kind of plan that out, because you don't want to be doing a migration and at the end have to re-up on a MuleSoft license. So we have to take that into consideration. One of the things that we've found worked well for our migrations is definitely following the Microsoft Cloud Adoption Framework. And with just a small tweak, we were able to make it work for integrations, where we go through the plan, the readiness, and the adoption, but then ultimately lower, we do the assess, deploy, and release in each integration. You'll see what are those iterations happening. And I call it out below, and we'll go through it with our methodology. And then after that, of course, you have to either transition the integrations back to the customer or have a partner that you can lean on for a managed support type agreement. I've also thrown in some links here that we followed, and you can reach out and ask for the slide, and I'll share that with you. I thought this was a clever way to talk about the MuleSoft model, because MuleSoft really disseminated this information. This is how you should do API-led architecture. This is how they call it a 3-tiered architecture for API-led development. But sometimes it was, people struggle with trying to understand it, and I really boil it down to, it's an old pattern. And so for those web developers that are here today listening, it's really the model view controller in 1995 when you were doing web development, where you try to, from a web app perspective, say, okay, well, when I build a web app screen, I may be managing work orders, but I might be only changing the status. So I'm only going to build a screen that kind of handles that. And if I'm doing payments, it's a payment screen. So they really tried in the MVC control world, MVC model, was essentially focus just views are very specific. So you're going to see in the MuleSoft, and I'll get into it, how they kind of just follow that same design pattern. Controllers were really about managing the interaction between the data, so that's the database layer, the file system layers, to the views. Again, views just to present to the users of the applications, and the controllers to mediate in between. And then lastly, the model is really interacting with the data, so grabbing the data and serving it up to the controllers. And the controllers is where the main logic was, right? So you would take the data, and you knew that all they really needed was work order number and status for that screen. So you'd filter and present it back. So if you follow model view controller in the web design, it's really the same thing in their 3-tiered architecture. And I'll have a diagram in a minute to show you, but it's the same concept. They take the notion of an experience layer where for each client, so you might have a mobile app and you'd have an exact API that serves just for that. You might have one that's for messaging, and you have an experience layer that talks messaging. So and SOAP, as an example, you might have a SOAP client connecting to your API, your integration. So you'd have one specific for that. And then process layer, this is no different inside the MuleSoft architecture. This is where they say, this is where all your business logic, your filtering logic, and processes can call other processes, but traditionally the processes will call system layers. And every one of these are trying to create abstractions. And then system layer is essentially, this is where you put in your security, your authentication, authorization, and all that stuff would happen in the system layer, data format, maybe reading SOAP response from a Workday application and transforming it into REST to pass to the process layer. So this is where you try to keep it clean. That's where all of the process or the system layer information will go. Visually seeing this is really what it looks like in their design, right? So we have experience layer, process layer, and the system layer. And each one just calls the next API down and then back. Our methodology, our migration wave methodology, really, we try to break it up into 2 parts. So we call it like the technology migration, and we're going to get into that, where it doesn't really have concepts around what is the business trying to achieve from a business process. When we look at systems integration, Systems integration is really when when a business process crosses, 2 or more systems. That's when we know we need integration. Well, when you're just connecting, in this case, to a system layer, there really isn't a lot of business process going there. So we try to break that up into technology migrations, but then last migrations that we really focus on is the business side of that. So you'll see how we separate that. This methodology addresses 2 concerns. We don't want to do big bangs. So how can we break this migration up into smaller pieces and deliver without having to go big bang? So you'll see how we do that. And then ultimately, it is an architecture that is followed by MuleSoft. So this methodology also says you don't have to redesign your architecture. We're not going to go through a whole redesign effort. So customers usually feel comfortable knowing that they've invested into this architecture. It's working, and they're just trying to migrate for optimizing their ROI on integration. So we don't want to redo it all. So first one, what we do is we simply just implement API management. So we take the Azure API management, and you'll see at every one of those layers, we just kind of front a proxy in front of the old calls. And really what this allows us to do is a couple things, is through configuration reroute calls. Second is we're able to stand up the old legacy MuleSoft APIs along with the new AIS ones, and we can do canary testing. So we can have round robin calls between the systems. We do 80-20 where they're hitting them. And then really what it allows us to do is just bug out, if you will, and address any performance issues, any logic that's wrong. It also allows us through configuration as well to roll back. So we can, well, that's not working, we can roll back to the MuleSoft one, do the updates, do the redeploy through DevOps, and then put it back into canary testing. From a technical perspective, really what you're doing is you're taking RAML, which is a specification that MuleSoft started with. They now support open API specifications, so you would have to go through a process of lifting that into open API. And then we would go through and update the MuleSoft configurations to now use API Manager for those calls. So visually what you're seeing is this is the 3-tiered architecture on the left-hand side. On the right-hand side, you're seeing these clients come in. They're now hitting this API management. We're routing that to the experience layer. And for every step along the way, it's also using API Manager management to actually front the calls. And this will give us flexibility later, and you'll see that. So then in migration effort number 2, after we've put API management in place, what you would probably want to do is look at the experience layer. It's pretty simplistic. It's really taking data and serving it to clients, a SOAP client, a REST client, messaging client. So it's technical in nature. It's not business in nature. So really what you're doing is you would look at rewriting what that process is. So you're taking a MuleSoft experience API and moving into an AIS service, and that can be a function, a logic app, it can be whatever you need it to be. Essentially, at this point is where we would do the canary testing, right? So, and then after we've identified that it's working, it's meeting the requirements, the performance is good, then we would also go into API management, update the configuration, say stop doing that, only call the AIS services now, because we've essentially at that point decommissioned the whole experience layer for inside the MuleSoft ecosystem. Then we will next tackle the system layer, because again, in nature, it technically is not have really little to do with business. It's really you're serving up interactions between backend systems of record through data lakes, doesn't matter. You're serving up one-to-one service system layer APIs. So in that similar concept, for each one of those systems, we write the compensating Azure AIS service. We take all that login information, we store it in a key vault, which is usually an enhancement to the customer's implementation. We update APIM also at that point to, again, follow the canary testing deployment after we've essentially tested and shown that it's working, we stopped that canary testing, and now API management is just showing at the system API layer. So at this point, this is what we have from an architecture. A majority of the work has been done, and the only outlier now is the process layer. From here, this one's a little bit more complex in nature, but what we would start to do is probably start with the least complex non-mission critical process that we could find. And because processes are, they could be calling multiple processes. So if a client comes in and says, I would like all the work orders in their invoice status, as an example, when it comes in, it has to call the work order process, and then potentially the invoice and the payment. So you can see in that one, what we want to do is migrate those three together to meet that full requirement for the business perspective for testing. So what we do is just logically group those, and we know that those are the ones we would migrate together, we would deploy together, we would go through updating API management, same way to get the canary testing. And then lastly, when we see that all working, we stop the canary testing, and now API management's fronting as the new process layers. At this point, we've achieved what we were trying to do. We've migrated everything over. We've not re-architected their implementation. We have not done Big Bang. We've done it in a very controlled way. And then lastly, what I would say is there's other considerations along that journey that you want to look at. We are pretty focused on making sure that we incorporate Azure Monitor and Log Analytics. I mean, it's such a step up from what MuleSolf has in that way. So we can get those metrics, dashboards, and ultimately, as we're doing that testing, we can see if there's anomalies going on. We've seen instances where we've actually improved integrations because that analytics has shown us where the bottleneck was, which ultimately, as we know, reduces cost. Clearly implementing DevOps. So there's two worlds. Either they're already using Azure DevOps, which works extremely well for getting in and deploying Azure componentry. So that works well. And if not, usually we go through a migration. If they're on another platform, we'll usually migrate them just for the benefits alone. And then lastly, security is a big one. So now that you're in the ecosystem, Active Directory integration is there for you, so we can usually tighten things up that way. We've seen an ask recently where we're starting to emit the right things for Sentinel integrate to Sentinel, so that customers are seeing benefits from that as well. That was quick, but that's what I have.
That was really good.
Yeah.
Yeah, we got one comment from Michael Stephenson talking about he really likes how you're phrasing that. It's like migrating to optimize the ROI, because that's why you're doing the migrations, right? You wanted to keep improvement on investment.
Yeah.
Didn't see any questions on the list so far, right? But we're going to be keeping Q&A after that. And if you have any questions, and also this is going to be available on YouTube. So if there is any questions after the show, you should still be able to see them and respond them there.
Yeah, fantastic.
Yeah, but thank you very much, Derek. Was really good. I like how you're doing the step by step, because I think that process is something that people can be quite daunting, right? I see a whole environment and don't thinking about how to slice it, dice it properly to actually making that migration process less daunting. So quite good. Thank you. Kent, any comments from you before we go to the next one?
No, I thought it was really good. Thanks, Derek, for joining us and sharing your knowledge. And folks, if you do have any questions about MuleSoft AIS migration, Derek's got his coordinates here, so I would just encourage you to reach out.
Yes. Okay, thank you. And all yours, Kent. You're doing I'm doing I'm doing the honors now. It's let's give it to Alex.
Yeah,
Alex,
there we go.
give you the honors to talk about this.
Alrighty. So I'm excited to announce that next month's live stream will be a special event called Azure Integration Services Day. So save the date now because this event will be on November 30th at our normal 11 a.m. PST start time. We have exciting presentations, demos, and more ready for you, featuring our friends from API Management, Service Bus, Event Grid, and Event Hub. So our event page is currently still being updated, but make sure to check out the blog link down below for more details as they become available. It's also important to note that our live streams normally occur on the fourth Thursday of every month. But for the sake of upcoming holidays in both November and December, Azure Integration Services Day will be our last Aviators live stream for the year, sadly, but we'll resume as scheduled in January. So we're looking forward to seeing you all there.
Yeah, you don't want to miss that one. It's not going to be 1 hour with all of that. We're actually going to be here for some time and bringing friends.
Yeah.
So I think that's the last announcement for the day. Don't see any other questions in here. So I think that's us for today.
Awesome.
Thank you everyone that joined, and just let me say bye. See you next time.